Alright, so let's look at this topic here, coordination number for ceramics. So what is coordination number? It means the number of anion, the bigger one, the number of anion nearest neighbors for a cation, the small one. Alright, so this coordination number actually increases with the increasing ratio of this one, the radius of cation divided by the radius of anion, which is also can be represented with RC over RA. So for a specific coordination number, there is a critical, or what we call as minimum radius ratio, for which this cation-anion contact is established. We have this cation and anion contact. So if this contact was to be established, there must be a certain minimum radius ratio. So this table here shows the ratio or the range for the radius of cation and radius of anion ratio. So if the ratio is less than 0.155, the coordination number is 2, okay? And the very small cation is bonded to two anions in linear manner. So this is what it looks like, okay? So if the ratio is between 0.155 to 0.225, the coordination number for the cation is 3. And it means that each cation here is surrounded by 3 anions in sort of like a planar triangle. And if the range of the ratio is between 0.225 to 0.414, the coordination number is 4. And the cation is located at the center of a tetrahedron. So this is a tetrahedron. Okay, so the cation is located at the center with anions at each of the 4 corners. So if you can see here, there are 4 anions here, 1, 2, 3, and 4. So this is the center. Okay, so 1, 2, 3, and 4, and this is the center. Okay, so the unit cell actually resembles this zinc blende, ZnS. For the radius between 0.414 to 0.732, the cation can be thought of as being situated at the center of an octahedron. So this is like an octahedron surrounded by 6 anions. The coordination number is 6. And for this type of arrangement, so the unit cell can be thought of to appear something like this. And this can be actually represented by NaCl, or sodium chloride. And the last one is between these two 1. They have 8 coordination number. The anions are located at all corners of a cube and a cation position at the center. So this is how the unit cell will look like, and this can be represented by this CsCl, or cesium chloride. So out of these lots, the most common coordination number for ceramics are 4, 6, and 8. So these are most common, which is the representation of zinc blende, sodium chloride, and cesium chloride. So this is an example on how we can use this radius ratio to predict structure of ferrum oxide. So the question is, on the basis of ionic radii, what crystal structure would you predict for ferrum oxide? So here is the list given for the radius of cation and the radius of anion. So you know that you have one ferrum and you have one oxygen here. So the radius of ferrum is the cation, which is the positively charged, and oxygen here is the anion, the negatively charged. So the radius of cation, which is this one, and the radius of anion, which is this one. So just substitute in this radius ratio equation and you get 0.550. So you refer back to this table here. 0.55 is somewhere somewhere here. So they have 6 coordinate number. So based on this ratio, the coordination number is 6 and the unit cell structure is sodium chloride. And that is the structure of ferrum oxide. It resembles the sodium chloride.